Welcome to the ATA College Math Clinic. I am just going to go ahead and get started with this today. We're going to cover a couple things that I know as nurses you guys will see pretty often. Hopefully you guys remember a lot of these things from your medical math class. If not, hopefully this is either a gentle reminder or, hopefully you learned some stuff today too. As you all know, I have all my lecture videos posted on YouTube. If you ever need anything else, anything in addition to some of the things that we'll chat about today, please feel free to reach out to me. And I can send you specific things on what you're looking for. So a couple things that we're going to take a look at today, some of the most popular things that you all see as nursing students, and that you'll see in your nursing career, of course. But conversions, we're going to take a look at household measurements, how to convert teaspoons, tablespoons, cups, ounces, those types of things. Just making sure we're fresh on that, as we see that a lot with I's and O's. We're going to look at basic dosage calculations, just making sure we feel pretty comfortable with medication administration. Dosages based on body weight, as we see oftentimes in pediatric patients. We'll take a look at IV calculations, and then we'll also get into even critical care applications. So let's just jump in. So getting started with the equivalents. So getting to know our equivalents for our household conversions was pretty important. This is one that our clinical coordinator provided to me, as this is something that you guys often will see, some of your basic measurement conversions. So this is something to make sure we're familiar with. If we're not, if anybody needs a copy of this, email me. I'll send it to you. Pretty easy. So hopefully these are all familiar to us. Because again, when we're asked to convert things, we want to make sure that we know that. If we don't know those equivalents, then it's hard to convert. So again, with those, there are a couple different methods for those household measurements. So if I say have 6 teaspoons and I want to know what that is in milliliters. So there's a couple different ways that we may have learned this. Hopefully, at this point or where you guys are, we have memorized that there's one teaspoon contains 5 milliliters. So based on that, if you all look at this, I'm hoping you guys can look at this and say, okay, well, if 1 teaspoon is 5 milliliters, 6 teaspoons would be 6 times 5. So therefore this would be 30. However, we discussed multiple ways to convert this. A couple different ways that you all may have been presented this. If it was from me, I went over 2 different methods. So one, anytime you're going from the larger unit to the smaller unit, you will always end up multiplying by your known. So it's always a multiplication problem. So meaning in this case, I am going from the larger unit to the smaller unit. And a way to remember that is to think, well, if 1 teaspoon is 5 milliliters, so here's a horribly drawn spoon, but to get the idea, 5 milliliters, here I'm going to use dots to represent milliliters. 5 milliliters must be pretty small if 5 of them fit into that 1 spoon. So therefore, teaspoons are bigger than milliliters. So in my question, I'm asking to go from the bigger unit and I'm converting it to the smaller unit. So that's why we end up multiplying by our 5, the number from our known. So that's one way to remember that. And obviously it would be the reverse if we were going smaller to larger. We'll look at that with the next example. But the other method, if you guys remember proportions, that was another way that we could, if there were students that needed to see a setup, and for those of you guys who are still early in medical math, maybe medical math was just last term and, we're still kind of getting to know these equivalents. If that's the case, then we talked about how you could set up a known equal to an unknown. So proportions, again, were set up as like 2 equivalent fractions set equal to one another. Known on one side, unknown on the other. Could be vice versa. Unknown down first, known on the other. Doesn't matter which side. As long as your units match up. Because a proportion is read like an analogy. So meaning if I say like this, 1 teaspoon is to 5 milliliters, as 6 teaspoons is to X amount of milliliters. So that's how a proportion is said out loud. We're using it as like, here's what I know about teaspoons and milliliters. Well, here's the question I'm being asked. So therefore, here's the unknown. Here's what I don't know. So if you guys remember with proportions, we solved proportions. Our shortcut for that was wherever X is in your equation, simply just cross multiply the opposite side and then divide by your last number. So in this case, 6 times 5 divided by 1, no matter which method you use, you get 30. And again, maybe you don't even think about this. Maybe you don't even think about this. Maybe if you're later in your nursing program, maybe you again can look at this and say, oh, that's times 5. If that's the case, fantastic. If we had the reverse of this, so meaning if I had 45 milliliters and I want to know what that is in teaspoons. So just based on the fact that I'm still working with teaspoons and milliliters, I'm still using the same known. One teaspoon is 5 milliliters. So again, 2 different methods. If I'm ever going from the smaller unit to the larger unit, sorry, handwriting is terrible, but you guys get the idea. We're always going to divide by the known. So in this case, again, if you remember what I mentioned on the previous question, that obviously milliliters must be pretty small if 5 of them can fit into that 1 teaspoon. So that's why milliliters are smaller. So in this case, I'm asking to convert from milliliters to the larger unit of teaspoons. So that's how I know I would simply just take the number from my question and divide it by the number of that known. So this is going to be 45 divided by 5 to give me 9. Now, again, for those of us that would prefer to see that proportion method, we could do the same thing. We could say, okay, well, 1 teaspoon is to 5 milliliters as X amount of teaspoons is to, 45 milliliters. So you can see what I did there. I wrote down the same known, but you notice that this time my X went on top because my X is the amount of teaspoons and it needs to be directly across from teaspoons, right? We're reading this as a relationship, right? That this relationship is equivalent to this relationship. So I want to make sure my units match up. So when I go to solve this particular question, since X is here, I cross multiply. This time it's 1 times 45. And then remember our rule for proportions was cross multiply, then divide by the last number. So I get 45 divided by 5. So therefore our answer is 9, regardless of the method we're using. And again, hopefully for those of you guys later in your program, hopefully this is something that you can look at and say, oh, well, if I'm going from milliliters to teaspoons, that's just divide by 5. So it takes some practice and it takes some making sure that we are continuing to look at those equivalents. And we're, again, by continually practicing with it, you'll accidentally memorize them. Really. I mean, I think you're just going to see that pretty often. The reason why I think, this is pretty important with, in the nursing program, you guys are going to see that pretty often when it comes to I's and O's as it, we're taking patient intake. So if we have a patient, for instance, let's say, so I'm going to use an example. Let's say we have a nurse, who is calculating patient intake at the end of her 12-hour shift. Okay, so I'm gonna make that a point too. It's a 12-hour shift, okay? And a nurse is calculating a patient intake for this shift. During this shift, her patient had a 6-ounce coffee. Let's say 8 ounces of juice. How about 2 pints of water? Maybe they're pretty thirsty that day. How about let's even say just a half a cup of, I don't know, let's say soda. And maybe let's say they were, this may not be a great situation, as you guys know, I'm not a nurse, so I don't even know if this would work out or not, but just kind of for the purpose of addition, taking this intake. Let's say they also had some type of maintenance IV that they were getting at 100 milliliters per hour. So I'm going to say an IV at 100 milliliters per hour, some type of saline or something. Like I said, some type of maintenance IV. So intake, when you guys see these, your intake, what the question will ask is, what is the patient's intake at the end of this shift? But we can't just add everything together right now. Most of the time it'll say, what is the patient intake in milliliters? Or even if it doesn't say that, that's kind of understood, that patient intake is measured in milliliters. And in this case, everything's in either ounces, pints, cups. We're seeing these different units. So in order to add all these together, we have to convert all of these into milliliters first. What's helpful with intake, as I mentioned to you briefly in the last couple examples, milliliters are small. Milliliters, as in the examples I gave you before, then whenever we're going from the larger unit to the smaller unit, we always multiply. When measuring intake and converting everything to milliliters, most of the time you're going to be multiplying, because if you're converting it to milliliters, that's kind of an easy way to remember that milliliters are generally always going to be your smaller unit. So therefore, we're typically going to be multiplying here. Like, so for example, with that 6 ounces of coffee, if we look on this sheet, so again, if we need a refresher, 30 milliliters is in 1 ounce. So that's what we're going to use there. So if 1 ounce is 30 milliliters, then 6 ounces would be 6 times 30. So therefore, the 6 ounce cup of coffee is the same thing as 180 milliliters. And what we'll do is we'll do the exact same conversion for each of these, just getting everything into milliliters, and then therefore we'll be able to add all of the intake together at the end. So we'll do the same thing with 8 ounces, since we're using the same unit here. 8 ounces, since there's 30 milliliters in an ounce, 8 times 30 is what we'll use here to see that that's the same thing as 240 milliliters. Pints should be on here, right? Maybe not. That's a common unit that I use, but maybe it's not on this one. But 1 pint, guys, 1 pint is the same thing as 2 cups. So therefore, because, well, this is just a basic one. 1 cup is 8 ounces, which I just showed you guys that 8 ounces is 240 milliliters. So a pint, so just if we may not see pints very often in nursing, but just, you know, for the purpose of our example here. So a pint, if a pint is 2 cups, then a pint would be double that. So 1 pint is 480 milliliters. So therefore, we're going to take 2 pints and we're going to multiply that by 480, and that gives us 960 milliliters of water. And that's what that patient just had with that over the course of 12 hours, of course. So it's not like they just, you know, had 2 pints, but a pint is not a ton of water. And then half a cup of soda. So I just showed you guys that a cup is 8 ounces, or we could look at that as, again, 240 milliliters. However you want to look at this, it's half of that. 8 ounces is, again, so if they had half a cup of coffee, or I'm sorry, half a cup of soda, they had half of this, right? So they had 120 milliliters of soda. Okay. And then the last one, the tricky part here, a lot of times people will read this and say, well, that's already in milliliters. So they had 100 milliliters of that IV. But keep in mind, that's 100 milliliters per hour. And the nurse is calculating this at the end of her 12-hour shift. So if this patient is getting 100 milliliters every single hour over the duration of that 12-hour shift, they had 100 times 12. So at the end of the day, or at the end of this shift, they had a total of 1,200 milliliters. So don't forget that when you see those IVs, that's kind of the trick there, that we have to pay attention to what the nurse's shift is. You may have a nurse that had only an 8-hour shift. And so calculating the, you know, intake at the end of his or her shift would be times 8. So something to keep in mind there. But the end part of this operation is we're going to go ahead and add all of these together. So I am going to need my calculator here. So let's see. All right. Excuse me, there it is. All right. 180 plus 240 plus 960 plus 120 plus 1,200 gives us a total at the end of this shift. This patient had 2,700 milliliters. Sorry, that's a 7. 2,700 milliliters at the end of this shift. So that's a big reason why making sure we get all these conversions down is pretty important. So don't forget to stay on top of those measurement conversions. Okay. All right. Another big thing we want to take a look at today are the dosage calculations. So if you remember for dosage calculations, and something I'll also send to you guys if you need it, we have, you know, some basic formulas that we'll follow as we go through some things today. Our dosage calculations formula, if you remember, is the D divided by H times Q. D standing for the dosage that's been ordered. H standing for the supply that we have on hand, and Q is the quantity on hand. If you guys remember, H and Q are always listed together in our problem because that's how the medication comes. If a medication is, say, like Advil, is 200 milligrams per tablet, so H in that case is the 200 milligrams per the quantity is one tablet. So since that's how medications are often listed, H and Q always come together because it's the supply. So we're going to follow our D over H times Q formula here and everything that we do in this next section as we take a look at dosage calculations. So dosage calculations can be pretty basic. I'm going to use Advil as an example that I just used. That if a physician says that a patient needs 1,000 milligrams of Advil, but Advil, when we look at Advil says that it is 200 milligrams per tablet or capsule, depending on the type of Advil you're taking. We can maybe look at that and say, oh, okay, well, patient needs to take 5 tablets, right? So sometimes you can look at it and they're pretty self-explanatory. They're pretty straightforward. However, they may not always be that way, but if we were to look at this one just to make sure we're setting that up correctly, just to kind of show that we're following the same process in all of our dosage calculations. Our doctor's order was this. That's what I mentioned at the very beginning, that's what the doctor ordered. So there's D in our D divided by H times Q formula. H and Q, as I mentioned, is your supply. So they're always together. There's H, there's Q. Okay, I know it says per tablet, doesn't give us a number, but 1 is assumed in that, right? It's per every 1 tablet. So there's 200 milligrams per every 1 tablet. So our answer at the end of this, when we take 1,000 divided by 200, gives me 5 times 1. My answer was 5 tablets is what that patient would take. And just as a reminder, you guys notice that, again, whatever my quantity is, the unit of my quantity is the unit in my answer. So since Advil comes in tablets, my answer is to give 5 tablets. And I point that out because in our operation, so before the equal sign here, in this equation, we had 3 different units, right? We have milligrams, milligrams, tablets. My answer is tablets. Therefore, what happened here with the other 2 units, since they were the same and on top of each other, so when they're numerator, denominator, and a fraction, when they're the same, they cancel each other out. So not that we have to know anything about fractions, but I say that because that's really important. That's kind of our big stipulation for the D over H times Q formula, is that D and H have to be the same unit always. Always. Because we want this to happen. I need them to cancel each other out so that therefore at the end of this equation, whatever my unit is for this quantity, that's the unit of my answer. So if they're not the same, we needed to do some converting, and that's where our metrics came in. Okay, so as a just quick reminder for metric conversions, either one, because the most common one that you guys will do is you'll convert grams into milligrams. So it's probably, where is that? Right here. So it may be just beneficial to just remember that 1 gram is 1,000 milligrams, because that's kind of the most common one that you'll do. Or know that, again, 1 milligram is 1,000 micrograms. That might be something you'll need to know as well. If that's the case, that's helpful. But for metrics, remember when you were taught it in the medical math class, we did 2 methods. For metrics, there was the chart method, which showed that how you can move your decimal. Silly, but we remembered a mnemonic device to remember the setup for that chart. And we said, kiss hairy dog's butt, drink chocolate milk, mom. And then M and O, remember, are your X's. Because this stood for, sorry if there's a little glare up there. These stood for kilo, hecto, deca, base. Remember, your bases are just grams, meters, and liters without any prefixes on those. Deci, centi, milli, and then 2 X's to represent those 2 place values. There's just no metric unit for those two, and then micro. So that method helped to show us that we can move our decimal. The other method was the stair-step method, that if you remembered only kilo, base, milli, and micro, that would be fine because that's all you're really gonna see in metrics. And so that method said that you could take those four, put them on a set of stairs here, whoops, that's a base, milli, and micro. And then just remember that anytime you go down one step, you multiply by 1,000. Anytime you go up one step, you divide by 1,000. So I give you that brief reminder because in the event that, let's say, we have an ordered dose, a patient needs to receive, let's say, maybe the doctor wasn't thinking and forgets that this medication comes in milligrams, okay? And he or she says the patient needs to take 2 grams of something by mouth, and we'll get to, so let's just say PRN for now. We'll get to twice a day, every 4 hours. I'll show you what we need to do when we get those types of abbreviation. And then we look on the label and we have a medication that comes as, let's say, 1,000 milligrams per 5 milliliters. Okay. Okay. So with that being said, yes, we could plug this into our D over H times Q formula right now. Just 1 second. Sorry guys, I had a few people that actually came in for the tutoring and had some specific questions, so I wanted to just stop the recording to be able to just kind of pick up where we left off. So I'm sorry our problem is still not written up here, so I apologize, but I remember that we were looking at how D and H needed to be the same unit, you know, in our D over H times Q formula. So I might not have the same exact equation up here, but just another example. If I have, say, 2 grams of medication is ordered in a medication that comes as 1,000 milligrams per every 2 milliliters, then again, there were 2 methods. Okay, so the 2 methods were again our kilo, hecto, deca, base, deci, centi, milli, XX micro chart, which again, don't forget that mnemonic device. So we've already talked about that. Or there was the stair-step method that said kilo, base, milli, micro, which said anytime we go down a step, we multiply by 1,000, up, we divide by 1,000. So in this case, if we were to plug this into our D over H times Q formula right now, this is what our problem looks like. I have 2 grams. Medication is our supply dosage per every 2 milliliters. So obviously D and H are not matching units, so we need to get them to where they are the same. Really doesn't matter which one you convert. The idea here is that you just convert one to match the other. So I can either convert the 2 grams into milligrams, and then therefore they'd both be in milligrams, or I can convert the 1,000 milligrams into grams, and then they'd both be in grams. Again, doesn't matter. You'll get your same answer either way, as long as you're converting one of them to match the other. But I always tell my students that milligrams is the most common, most popular unit that you'll see in nursing math. So I get everything into milligrams, typically. So what that means is I'm going to take this 2 grams and convert it into milligrams so that we will then therefore have matching units here. Well, how do we do that? Well, that's where, again, one of our 2 methods of converting come in. Some may say, again, if you just have that known memorized, that 1 gram is equivalent to 1,000 milligrams, in your head, you're probably just taking 2 times 1,000, which is fine. That's essentially what we're doing on the stair-step method to go from base to milli, right? That's what we're doing. Your base is 2 grams, right? So grams, and you're converting it to milligrams. So that's times 1,000. So for those of you guys who just have that known memorized, you're doing the same thing there. For those of us that would prefer that decimal movement chart, base to milli is 3 places to the right. Okay, so that's 3 places. So that means I'm taking my decimal that's behind the 2 and that whole number 2 and moving it 3 places to the right would make it 2,000. So again, no matter which method you use, or again, if you just have that known memorized, 2 grams, and we're not changing the doctor's order, 2 grams is just the same thing as 2,000 milligrams. So now I can go ahead and divide this now that they're the same. So 2,000 divided by 1,000 is 2. times 2, my answer here is 4 milliliters. That's what they need. And like I said, so that's the basic thing that we need to remember for our dosage calculations is D divided by H times Q, just simply making sure D and H are matching units. And we would do so no matter how that is worded for us. And that's what I want to take a look at and what I see with a lot of our nurses, sometimes these dosage calculation questions, the units don't match, so we have to do some converting. Sometimes we have where we're given an order dose that gives us an amount of time that needs to be given in, or over the course of a certain amount of time, and we have to calculate the daily dose as well. So that's important. So I'm going to look at one like that. Sometimes there's extra information given to us that we don't need to incorporate in the problem. And sometimes we have dosages based on body weight. So all of those would still use the D over H times Q formula, but just maybe applying it differently. So I'm going to start with one where we have an ordered dose. So let's say I have an ordered dose of, say, 400 milligrams to be given by mouth, and let's say every 6 hours. Okay, so that time I'm going to actually incorporate into this particular problem. Say we have a medication that comes as 100 milligrams per 5 milliliters. Okay, so plugging this into our D over H times Q formula, we would do the same thing that we've been doing so far. Order dose is 400 milligrams. We have a medication that is 100 milligrams per 5 milliliters. So when I divide this out, 400 divided by 100 is 4 times 5. My answer here is 20 milliliters. But all we've done is taken this order dose of 400 milligrams and said, well, that is the same thing as 20 milliliters, right? So that means they need 20 milliliters every 6 hours. So in the event that the question at the end of this said, what would the patient's daily dose be? Or maybe it asked for both. Maybe it asked for a single dose, which is what we'd have here. That's what they would get in order to get the 400 milligrams, right? So they would need to take 20 milliliters to get that. So that would be 20 milliliters every 6 hours. So that's a single dose. So to figure out what they need in a daily dose, that means they're taking this every 6 hours or 4 times in a day, right? And the reason why we think about that way is because in a 24-hour day, every 6 hours, that's an hour, sorry, is going to be 4 different times. So that's why here, if they're taking 20 milliliters to figure out what that daily dose is, they're taking that 4 times. 20 times 4 is 80. So there's our daily dose. So it's a matter of just incorporating kind of what, how often they're taking that medication. And it's just a matter of how that problem is worded. Those students who just came in here a second ago, they actually had a problem worded very similarly, but we had to kind of do the reverse. And here's what I mean. We had a problem that looked like this. Instead, this one said the order dose was to take 400 milligrams per day. And then same thing, we have a medication that is 100 milligrams per 5 milliliters. And then it asks for the single dose. So again, the idea here is to remember that this is the order dose was told as the daily, that it's 400 milligrams per day. So when I calculate this out in the D over H times Q formula, 400 milligrams divided by 100 milligrams per 5 milliliters. So there's D, H, and Q. That's where that came from. Again, I still get 20 milliliters, right? Well, that's what they're going to take to get this amount, but this amount was ordered per day. So that means they're needing to take 20 milliliters per day. So the other part of this calculation, the part of that ordered dose, so which I didn't write down here, it said to take 400 milligrams per day. It said by mouth in in 3 equally divided doses. So there's the key there, that yes, 20 milliliters is what they're going to end up taking per day based on what that says. But the part right behind that said that they're going to take that overall. That's what we're going to end up taking throughout the whole day. but they said, don't take it all at once. Don't take it all at once. So in other words, don't take this 20 milliliters all at once. Instead, divide it into 3 equal doses. So that in that case, we would simply do as that says. 3 divided, so we would just divide this answer by 3. So we get a decimal here, end up getting like 6 point something, 20 divided by 3 is 6.7. So that means that they need 6.7 milliliters 3 times throughout the day. And then ending up giving them 20 milliliters overall. So just some things to look out for, just to make sure we're paying attention to how often a medication is given, and pay attention to kind of how that question is worded. So be on the lookout for that. Also with dosage calculations, we can incorporate weight. Okay, so don't forget, we need to incorporate patient weight, in a lot of times in pediatric medications. So if we have let's say a patient that weighs 44 pounds, and we have a medication that says they're ordered to take 5 milligrams per kilogram by mouth. And of course, we can incorporate the same thing we just did, and every 12 hours or so often. But let's just look at this for now. We have a medication that comes as 50 milligrams per every 2 milliliters. So with these types of questions, the ones that say per kilogram, we're still incorporating this D over H times Q formula. H and Q are still given to us, right? So if we were to write out our dosage calculation right now, we already have H and Q. The only thing we're missing here is the ordered dose. The ordered dose, although it says 5 milligrams per kilogram, that's kind of like a generalized dosage for anybody taking this drug. So for our patient who's 44 pounds versus our patient who's only 10 pounds, or our patient who's 75 pounds, right? All 3 of those patients can take the same drug, but they're just going to take a different amount of that drug based on that weight. Patient who weighs only 10 pounds is going to take less than this child, whereas our patient who's 75 pounds is going to take more than this child. So that's where this comes in. Is we're still going to incorporate the D over H times Q formula. We just have to figure out what is this order for our patient. Okay, so our first step, 44 pounds, obviously this order dose is per kilogram. So we have to first figure out what is that in kilograms. So don't forget to convert pounds to kilograms, just a simple divide by 2.2, and 44 divided by 2.2 is 20 kilograms. So what that means is, since this order dose says 5 milligrams per kilogram, it means they need 5 milligrams per every one of those 20 kilograms. So our next step here is just to multiply. So we're simply going to take 20, multiply it by 5, and that's where this number comes from. So 20 times 5 is 100. So our 44 pound patient needs 100 milligrams as the ordered dose. And now we can finish our dosage calculation. 100 divided by 50 is 2 times 2, so 2 again, is 4 milliliters. So that's where that comes in. So with weight, just again, first step is to simply convert it. If it's in pounds, that's all, if it's already given as kilograms, obviously you don't have to do anything. But if it's given in pounds, our first step is to convert it into kilograms by dividing by 2.2. Once we get that number, we're multiplying by this number. Okay, that wherever it says milligrams per kilogram, you're multiplying by that number of kilograms. And then again, like I said, that tells you what the doctor's order is for that patient because of their weight. And we just plug it in accordingly. So remember that with dosages by weight. So before I get into IVs, I'd like to look at, and I've pulled up, so excuse my giant face here. I want to share, I've pulled up some sample ones that I've received some sample, maybe not minute. No, I don't want to use this one. Sorry, I've found some sample dosage calculation problems given to me by nursing instructors. So I want to make sure I'm looking through some examples to make sure we feel pretty good about these. So this is some math practice, again, using the D over H times Q formula. So just to show you how some of these could be worded. So like looking at that first one, provider prescribes 0.25 milligrams by mouth daily. Sorry, I don't know these medications as well as you nurses do. That's your all's job. I just know the numbers. Pharmacy supplies the medication as 0.125 milligrams per 5 milliliters. So that one, guys, is simply going to be, here's your doctor's order. So the 0.25 is D in our D over H times Q formula. 0.125 is H and 5 is Q. So it would just be 0.25 divided by 0.125, which is 2 times 5 gives me 10. Okay. So same idea here. I want to see some examples where maybe we're going to have either some converting, or these are all some pretty basic. We'll get to those later. Oh, another good thing to look out for here. This instructor has given a great example. Pay attention again to the question being asked. Pay attention to that question being asked. So like here, number one, provider prescribes tetracycline 500 milligrams by mouth every 6 hours. The pharmacy supplies the medication 125 milligrams per 5 milliliters. How many teaspoons will the nurse administer? So again, when you're looking at a D over H times Q formula, with that, so let's look for just a second. D over H times Q formula, again, takes, how that supply is given, and I apologize, I just forgot what that was. Let's see, where was that? Sorry, I want to make sure I have the right numbers. 500 milligrams, take by mouth, it comes, the supply is 125 milligrams per 5 milliliters. So remember, D over H times Q formula is simply taking that order dose and converting it to, sorry, I want to make sure I'm sharing this correctly, is converting it to whatever this unit is of the quantity, right? So 500 divided by 125 gives me 4, times 5 gives me 20 milliliters. So it's taking, again, what's been ordered and converting it to how the medication comes. So it converts it to milliliters, not teaspoons. So that's going to go back to the very first thing we talked about, is remembering, well, there's 5 milliliters in every teaspoon. So if the answer was 20 milliliters, we're simply just using those household conversions. To convert that into teaspoons, we would simply just divide by 5 here. So 20 milliliters would be the same thing as 4 teaspoons. So keep that in mind, and pay attention to how the question is being asked. Another couple examples I saw that I think were pretty helpful were like on this worksheet. This is going to be, sorry, not just yet. We're going to see milliliters per hour. I thought for some reason this was one. Well, we can look at a couple of these just because these are going to be some dosage calculation questions. So provider prescribes 2 milligrams per kilogram to take by mouth twice a day. The client weighs 165 pounds. The pharmacy supplies the medication in 50 milligram tablets. So again, as we mentioned, when it comes to weight, so let me write this down. So 165 pounds, 2 milligrams per kilogram, and they are supplied in 50 milligram tablets. Okay, so just as we've done before, when it comes to these medications based on weight, our first step is, again, to first convert our patient's weight into kilograms. So 165 divided by 2.2 is 75. So there's 75 kilograms. They need 75 times 2 to get, to see what their order dose is. So that means their order dose is 150 milligrams. So that's D in our D over H times Q formula. And again, they came in 50 milligram tablets. So there's our H per 1 tablet is our Q. So our patient here would end up taking 3 tablets. Okay. Okay, so just make sure we're paying attention again to the question being asked, what's being asked at the very end. Incorporating weight when we need to by dividing by 2.2 to get our ordered dose. So those are some key things in those dosage calculation type questions. So now I want to get into IV calculations. So IVs, your most common things, and anybody who needs this is the formula sheet for our IVs as well. So I mentioned this earlier when I was pointing out the dosage calculations. But for IVs, these are your IV formulas. Here's your formula for drops per minute, which is a pretty common one. Volume divided by time times our drop factor. Another big common one, I call it flow rate on this worksheet. Oftentimes you're probably just asked to calculate milliliters per hour. Oftentimes that's how we set the infusion pump, sometimes set as the infusion rate. So that might be asked a number of different ways, but oftentimes it's just worded as milliliters per hour. So to calculate milliliters per hour, if you're given the total volume in milliliters, total time in hours, you just divide the two. And then these are not as common, but you'll see. And that's calculating your flow rate or your IV's time. So how long a medication or an IV will be delivered. If that's the case, you'll be given a total volume. And if you're given a total infusion rate, so say a patient is receiving a total of 1,000 milliliters at a rate of 100 milliliters an hour, well, that would be just 1,000 divided by 10. I'm sorry, 10's the answer. 1,000 divided by 100 milliliters per hour would give us a total of 10 hours. So we should be able to calculate the time using that formula. And then sometimes if we're given the, let's say we're given the infusion rate, so the milliliter per hour rate, and the total amount of time that's to be administered, from that information, we can calculate the total volume that they're going to receive at the end of that IV. So that's where those different formulas come in. So it's good to know those formulas. If you need to, screenshot it without my goofy face in it, screenshot it, or again, just ask me and I'd be glad to send that to you guys as a quick reminder of our formulas for IVs. So starting with the drops per minute formula, again, remember that was just simply volume, and I have in parentheses there milliliters to remind us that it needs to be in milliliters. Time, we are calculating drops per minute, so of course our time needs to be in minutes, and then we're going to multiply that by a drop factor, which is based on the size of the tubing. It's oftentimes given as a drops per milliliter infusion rate. Can be given either way. It's either told to us as a drop factor or drop per milliliter rate. But either way, with that information, we can calculate drops per minute. So if we are told, and again, I want to point out that this is the unit this needs to be in, this is the unit that needs to be in. This is going to be given to us. So don't need to think anything about that. If they're not, we might have to put it in those units. So for instance, if a patient was told, a nurse was told to administer 2 liters over the course of 8 hours using a, I don't know, 60 drops per milliliter rate, or using micro drip tubing, which is 60. And then it said to calculate drops per minute. Drops per minute. Can't write today. Then here's the things we need to make sure of before we plug this into our formula here. Since our volume is given to us as 2 liters, remember we need it to be in milliliters. So that's going back to our metric conversions. Liters is one of our bases. And we're trying to convert it to milli, right? We need to convert it to milliliters. So that's, again, if you're using your metric chart, that's 3 places to the right. Or for the stair step method individuals, that's base to milli. So that's times 1,000. Okay. So either way, 2 liters is the same thing as 2,000 milliliters. So that's what I'm going to use in this equation. I'm going to divide by the time. The time was given to us as 8 hours. Don't forget, when I'm calculating drops per minute, I need it to be in minutes. So 8 hours, there's 60 minutes in an hour. So I'm going to take 8 times 60 to determine that that's 480 minutes. That's what I'm going to use here. If we used 8 hours there accidentally, then that means you're going to calculate drops per hour by mistake, and you're going to get a really big number. So hopefully that's something to signal you that you're off, that you may have forgotten to convert your hours to minutes. Okay, and then we're gonna take that and multiply it by our drop factor, which is 60. Okay, so from there, we're gonna do, it looks very similar to a dosage formula with a number divided by one number times another. So it's 2,000 divided by 480, take that answer, multiply it by 60, and that gives us, okay. Probably won't have something that's 250 drops per minute, but you guys get the idea. 250 drops per minute here. Always keep in mind that drops should always be rounded to the nearest whole number. In this case, I ended up getting a whole number, but if you ever don't get a whole number here, drops will always be rounded to a whole number. Because you can't regulate the size of a drop. You know, if you think about how you use a dropper, I can't give 0.3 drops. I don't know how to do that. So you wouldn't here in this case here either. Okay. So that's our drops per minute formula. Volume divided by time multiplied by our drop factor. Just make sure our volume and time are in the correct units. Milliliters, minutes. All right. Our infusion rate. Infusion rate formula. If you're ever just asked to calculate milliliters per hour, that formula is simply just volume. Make sure it's in milliliters and divided by your time in hours. You can see if I'm given my total volume and my total time, if I'm trying to calculate this, look at the units. All I need is those two. So milliliters divided by hours. So meaning I can take the exact same question that I was just given, even though it said calculate drops per minute right there. What if it said to calculate milliliters per hour? In this case, my drop factor is kind of irrelevant, so you can just ignore it. I'm just calculating the milliliter per hour infusion rate, which would mean I would take my 2 liters, again, needs to be in milliliters. So I'm going to use my 2,000 milliliters, right? Not the 2 liters. And I need my time, which is in 8 hours. I'm not going to convert that to minutes because I'm calculating milliliters per hour. So I need it to be in hours. So in this case, it's simply just taking 2,000 divided by 8, which is going to be 250, right? I don't know why I feel like I have to verify that, which is 250 milliliters per hour. There we go. There's just volume divided by time. In the event that you were ever asked to give maybe a smaller IV over a course of a shorter amount of time, like for instance, if I was asked to administer 50 milliliters over 30 minutes, and then I was asked to calculate milliliters per hour, or asked, you know, how would you set the infusion pump? That would simply be just taking volume divided by time, right? But in this case, volume divided by time, if I divided this out, I'm calculating milliliters per minute. And I don't want that. I want milliliters per hour. So in this case, you would just do the same thing we did on the previous example, but the reverse, right? In the previous example with our drops per minute, when I needed my time to be in minutes, I multiplied it by 60. Here, my time is given to me in minutes, but I need it to be in hours. So we simply just do the reverse. You could say, well, 30 minutes divided by 60 is half an hour. In a lot of these cases, guys, when you're given IVs over the course of a short amount of time in minutes, most of the time it's either 15, 30, or 45 minutes. So one way to remember that, instead of having to divide by 60 every time, which is great, is a great way to know that if you ever needed to convert minutes to hours, just divide by 60. But in a lot of these IV equations, you can memorize this. You can remember that this is pretending like this is a clock. So imagine there's 12 at the top here and then 1 through 11 up here. But know that 15 minutes in, that's 1/4 of an hour, right? 30 minutes in is 0.5, is half an hour. 45 minutes is 3/4 of an hour, right? If we block this clock off into quarters, and then of course there's a full hour. So a way to remember that is 15 minutes is 0.25 hours, 30 minutes is 0.5, and 45 minutes is 0.75. So just if you ever happen to see that. And so what we would do here is now we would just divide it like we did before, milliliters divided by hours. We would set the infusion pump at 100 milliliters per hour here. they would only just get it for 30 minutes based on what they need. Okay. So that's milliliters per hour. Like I said, the other two formulas, guys, are not as common. I see these more often, the drops per minute and milliliters per hour. But they still come up. So, you know, something to be familiar with. If we ever need to know how long an IV is going to take, so our time, to calculate the time, we're simply going to take that total volume and we'll divide it by, I'm going to call it F for flow rate, but again, it's just your milliliter per hour rate. So milliliter per hour rate. And you'll see what happens here is milliliters and milliliters canceled out, leaving me with what I need, hours. So if we were told that we need to administer, let's say 1,500 milliliters at a, I'll do one, it's kind of easy. First, 150 milliliter per hour rate. So that's what they're getting over the course of each hour. And they need to do that until they reach 1,500 milliliters. Well, that should help us determine how long this IV will take. So following that formula, it's simply just taking 1,500 milliliters, dividing it by that 150 milliliter per hour rate, which means this is going to take 10 hours. And that'll work every single time. Simply just taking that total volume divided by that flow rate will give you the amount of time. And then be prepared to see, I want to do one that's going to work out this way. Let's say, no. Okay. Let's say we were told to administer 2,000 milliliters at a 160 milliliter per hour rate. Same exact thing, guys. We're just going to take that the total volume divided by the flow rate. And you'll see here, when you get that answer, you end up with 12.5. So 12.5 hours, as we just saw from the previous question, we know half an hour is 30 minutes, right? So in this case, 12 and a half hours. So that would just be, you know, 12 hours and 30 minutes, depending on how your instructor is wanting you to answer this question. So be prepared for that 12.5 might be an acceptable answer here, but they may be looking for that 12 hours and so many minutes. If you need that specific, again, here, we just have 0.5 memorized. But if you ever get something other than 0.5, you can always take that decimal times 60, and 0.5 times 60 is 30. So that tells me this is 12 hours and 30 minutes. So regardless of whatever that number is behind that decimal, you can get your minutes that way. Okay. And another way that I see these types of questions worded, are the same way, but sometimes, you know, there might be additional information that says, if this IV started at 8 a.m., what time would this IV be complete? You know, so be prepared to then incorporate that. And keeping in mind, we have to know our military time too. So if it said that the IV started at 0800, that yes, 12 hours later, and then another 30 minutes, of course. So 12 hours and 30 minutes later would be 8:30 p.m., right? So we have to know what that is in military time. So this would be complete at 2030. Okay, so be on the lookout for those types of questions too. All right, and then the last formula for our IVs was looking at volume. So if we were given instead, you'll notice the last three formulas I've looked at are just the same formula rearranged, right? Based on the information that we have. If we are given the flow rate, or in other words, the milliliter per hour rate, and the time, so our hours, we should be able to figure out how much total volume that patient is going to receive. So if I was told that a patient is receiving an IV at 150 milliliters per hour over the course of 8 hours, I feel like I'm gonna sneeze again. And it then said, how, all right, faster than my hands can, or think faster than my hands can move. How many milliliters will the patient receive? So in that case, it's just 150 times 8, which is 1200. So they would receive a total of 1,200 milliliters. So again, this is the only formula where you're multiplying the two numbers. Most of the time we're seeing division, but here, again, based on that information, 150 milliliters every single hour, 150 milliliters this hour, they're doing that 8 different times. It would be 150 times 8. And that tells us our total volume. Okay. All right. Last thing I oftentimes see, so if you're kind of early on, you know, maybe you've only seen some household measurements so far, some dosage calculations, some IV calculations. Maybe you're not quite here yet. I know I cover this in math, so hopefully everybody's familiar with this, but critical care applications. In critical care problems, we are given a dosage of medication, and I want to know how to set the IV pump. So in this case, we're going to use our dosage. We're kind of combining what we just looked at, the dosages and IVs, but not really combining formulas. We're still going to use the D over H times Q formula, but applying it really kind of in different ways. What I mean by that, like for instance, I'm gonna start small and then I'm gonna build on this. So critical care applications. So if you don't need this just yet, maybe you're not looking at this quite yet in your nursing program, you might not need this right now, but hang on to this. But if let's say, and this should be easy right now for those of you guys even who haven't seen it or haven't seen it in a while, because right now I'm just looking at it as a dosage formula, and really it is easy. I should say that. But if I'm ordered to take 100 milligrams per hour, and the medication comes as 50 milligrams per 2 milliliters, I would still use a dosage formula. The only difference between what we've seen so far with our dosage calculations and this one is this right here. But all this means is that the order dose is what a patient needs to take per hour. So whatever my answer is what they need per hour. Okay, because again, a dosage formula is simply taking that order dose and converting it into how it comes. So if I have 100 milligrams for a medication that comes as 50 milligrams per 2 milliliters, my answer I know is 100 divided by 50 is 2 times 2 is 4 milliliters. But since that order dose was 100 milligrams per hour, my answer is per hour. So here, like I said, I'm going to slowly build on this. If you're ordered to take a certain amount of dosage, in this case, it was milligrams per hour, and I want to figure out what a patient needs milliliters per hour. Again, converting from milligrams to milliliters, you have to incorporate the supply, how the medication comes. So the D over H times Q formula there. Here, we didn't have to do anything because it was already ordered in hours if I want it to be in hours. So we're good there. That's checked off. We don't have to do anything. So this was just kind of a basic dosage calculation. Okay. What if this said that we have a patient who needs 100 milligrams per minute? A little different. Okay. Not too much different. Okay, same problem. We need to incorporate a little bit differently. Here, so going back to my little diagram here, the difference is, so it's still milligrams that we need to get into milliliters. So we're still going to use a D over H times Q formula, but milligrams per minute, but I need it to be hours. So we have to do something differently here. And that's just simply incorporating what we know about minutes and hours. And there's 60 minutes in every hour, right? So we're going to end up multiplying by 60. And here's why. Think about this. If a patient is ordered to take 100 milligrams every minute, they're going to do that this minute. They're going to do that again the next minute. They're going to do that again another minute. So again, they're going to do that a total of 60 times in an hour. So if we simply just take that 100 minutes and multiply it by 60, that means that this patient, their order dose is the same thing as 6,000 milligrams per hour. Now we've checked this off. Now I just need to put in that dosage calculation, just like I did in the previous question. The previous question was an order dose per hour. So when I plug this into our D over H times Q formula, my answer is now milliliters per hour. And that's what I want. So if I took 6,000 divided by 50, multiply that by 2, it's 240 milliliters per hour. So see, just a little bit different. We just have two different steps that we need to incorporate here. That's all that's happening in these types of, these are, like I said, these are called critical care applications, or if I'm given a dosage and I need to figure out what that is in a pump setting, so milliliters per hour, that's how we would calculate this. Okay, so just based on how that's given to me, how do I get here? Okay, so that's what the question is going to ask, is what would this be in milliliters per hour? Okay. So let's look at another one, but a little bit different. Let's say that a patient, let's say was ordered to take, well, let's say 50 micrograms per minute. And we have a medication that comes as, let's say, 60 milligrams per 100 milliliters. I write numbers down, don't know if it's going to work out or not. So we'll figure this out. Okay, so first step, again, kind of same things are happening here. Don't be thrown off by that micrograms just yet. We're gonna bring that into our dosage calculation and what we know about dosage calculations. So if this is our order dose, keep in mind again that it's per minute. So anytime we see per minute, my advice is to just multiply by 60 because that's going to go ahead and take care of this step right here. Okay, so if I do that, 50 times 60 is 300. Sometimes my brain malfunctions. So 300 micrograms, but now per hour. Okay. All right, but it's still micrograms, right? It's still in micrograms. I haven't done anything to that. If I were to plug this, because then our next step, so we've taken care of that. So next step is plugging that into our dosage formula. The difference here is that if I plug this into D over H times Q, so divided by 60 milligrams times 100 milliliters, we run into a slight issue, right? Our dosage ordered is micrograms, but our dose on hand is in milligrams. So what we know about dosage calculations is we need to get everything, D and H need to be in the same unit. So I'm going to, again, as I mentioned, I typically just get everything into milligrams just out of habit. So I'm going to take that 300 micrograms and convert it into milligrams so that it matches. Okay, so we're, again, dosage chart, metric chart. Micro is the very last unit, and I want to convert it to milli, right? Micrograms to milligrams would be 3 places to the left. Or for those of us using the stair step method, micro to milli is up 1 step. So therefore, that's going to be taking this number and dividing it by 1,000. Either way, we see that 300 micrograms is the same thing as 0.3 milligrams. Now that they both match, now I can do the D over H times Q formula. So here 0.3 divided by 60 and then times 100, I end up with 0.5 milliliters per hour here. So not a great example, but as far as numbers, so I apologize on that, but you guys get the idea that that's how we would take that if we were given an order dose of micrograms per minute. First, multiply that by 60 to determine what that is per hour. And then again, once we have any type of dosage, if we want to convert that to milliliters, we use our dosage formula. But just keep in mind that D and H have to be matching units, so we might have to convert. Okay. And these critical care applications can look a little bit different in one other way. Could incorporate weight. So if you ever get a question that says, if maybe an order dose is to, we need 3 micrograms per kilogram per minute. Okay, so I'm taking pretty much what was in the previous question, but I've added this per kilogram. So we're going to add just one additional step into here. So how this medication comes is, let's say 50 milligrams per, let's say 500 milliliters. And we have a patient who weighs, let's just go ahead and have it in kilograms to make it easier on us. And so again, the question is asking us, what would this be in milliliters per hour? So again, back to our diagram over here. So yes, whenever we see per minute, we're gonna incorporate 60. The difference here is it's not just, you know, a dosage. I know that that said milligrams, but micrograms, we would do the same thing. The difference is here, there's this one extra little step in here. And anytime we see per kilogram, as we saw in dosages based on body weight, anytime you see per kilogram, you're simply gonna multiply by those kilograms. If they need 3 micrograms per kilogram, that means they need 3 micrograms for every one of those 75 kilograms. So we could take 3 times 75 to get rid of that part. So here, this is just gonna be kind of 3 different steps. So let's plug that in. So I'm just gonna kind of start with my additional steps so that then it can look like the most previous question that we did. So the most recent one. So if I, like I said, just based on the order that it's kind of going in here, if they need 3 micrograms per kilogram, that means they need 3 micrograms per every one of those 75 kilograms. So if I take 3 times 75, that tells me that my patient needs 275, and I'm just going to erase this. They need, I'm not 275, I'm sorry, 225 micrograms per minute. All I've done so far, guys, is eliminate this part so that now it looks like my previous question. Okay, so I've done this. I've gotten rid of the per kilogram. Now, again, keep in mind, if they need 225 micrograms per minute, they're going to end up getting this amount 60 times in an hour. So to go ahead and figure out what that would be per hour, 225 times 60 is 13,500. Now it's per hour. So I've taken care of this step. My last step is to put that in a D over H times Q, because again, I'm taking any type of dosage. In order to convert that to milliliters, I have to incorporate the supply. Okay, so I'll do this over here. So that was 13,500 micrograms. And then H and Q is 50 milligrams per 500 milliliters. Sorry, my head's blocking that, what was given to us earlier. So again, just what we know about dosage formula is we need D and H to be matching units. So as I did before, I'm going to go ahead and convert those micrograms into milligrams by moving 3 places to the left, or again, up 1 step would be to take this and divide by 1,000. So either way, 13,500 micrograms is 13.5 milligrams. So here to get my answer, I would plug this into the dosage calculation formula here. 13.5 divided by 50, and then take that times 500. This patient needs 135 milliliters per hour. And those, like I said, are real quick examples of critical care applications. So hopefully that helps with some of the things that you guys are seeing in some of your nursing courses. I know that last part was kind of quick. So if you guys are coming across these, please don't hesitate to give me a call, shoot me an email. If you just need some additional help, I've got other videos. I've got a lecture video on this. But I can also go over some stuff with you guys if you ever get stuck on anything. So just let me know. All right, guys, have a great day.